Welcome to this video about section 1.8 in geometry, statements of logic. This is actually a really interesting section with some maybe new and interesting things to think about. The first thing that's presented is that the difference between a declarative statement and a conditional statement. And you'll probably recall that I've been really insistent on using conditional statements, and this section really makes it a great example of why conditional statements would be useful. So a declarative statement, an example of a declarative statement is two straight angles are congruent. Okay, that's a declarative statement. Two straight angles are congruent. A conditional version of the same statement would be if two angles are straight angles, then they are congruent. Okay, so you can often write declarative statements as conditional statements. Just wanted to point that out because that becomes useful later. Okay. So this section introduces some new types of statements. We've seen original conditional statements, so things like this. P implies Q, which is if P, then Q. Okay, or P implies Q. You could say it either way. The converse of that is to simply switch the order. Q implies P, or if Q, then P. Okay? The inverse is the negation of the original. So the original statement is P implies Q. The negation would be not P implies not Q. So the negation of P implies the negation of Q. So if not P, then not Q. And the negation simply is this not P, like this, not P. Okay, the tilde P means not P. The contrapositive, the converse of the inverse, means you switch it, the order, and you make both of them negative. So not Q implies not P. So if not Q, then not P. Okay? So these are just things that you should probably commit to memory or make a note of somewhere, that these are the notations for the four basic versions of the statements. So let's look at the examples. If you live in Lower Merion, then you live in Pennsylvania. Okay, so we'll just take that as a true statement. The converse would be switching the order. If you live in PA, then you live in Lower Merion. That would be the converse, simply switching the order. Okay? The inverse would be negating the original. If you don't live in Lower Merion, then you don't live in PA. Okay, so that would be the inverse of the original statement. And finally, the contrapositive would be the switching of the order and negating of both parts. So if you don't live in PA, so I'm switching the order and making them both negative, then you don't live in Lower Merion. Okay? So you can construct all of these different statements based on the original. However, not all of them are necessarily true. So let's take a look at this Venn diagram. This says you may use a Venn diagram to determine whether or not a conditional statement is true or false. So for example, the first one says if Mr. G lives in Lower Merion, there's Mr. G, he lives in Lower Merion, then he must live in Pennsylvania. That is true. That's the original statement, right? So number 2 says, if Mr. G lives in Pennsylvania, then he must live in Lower Merion. So let's look. If Mr. G lives in Pennsylvania, he must live in Lower Merion. Well, if we look at Pennsylvania, Pennsylvania is pretty large. Mr. G could live out here, right? Mr. G could live out here, in which case he would live in Pennsylvania but not live in Lower Merion. So that's not necessarily true. We'll say false, and that's because I've created a counterexample here. For number 3, if Mr. G doesn't live in Lower Merion, then he doesn't live in PA. Okay? So I've constructed an example where Mr. G doesn't live in Lower Merion, but he still does live in Pennsylvania. So I'm going to say this one's false also, again, because I've constructed a counterexample. And finally, number 4 says, if Mr. G doesn't live in Pennsylvania, so if I put Mr. G outside of the Pennsylvania circle, put him out here, then he doesn't live in Lower Merion. That appears to be true, because there's no way he could be in Lower Merion if he's not even in Pennsylvania. Okay, and we're assuming there's only one Lower Merion, and it's in Pennsylvania. So this is how we can use a Venn diagram to simplify this process. All right, so you'll notice that this is theorem 3. If a conditional statement is true, then the contrapositive of the statement is also true. So let's just backtrack. If the first statement was true, then the contrapositive is also true. Okay? So that is our theorem here, that if P, then Q, so if that's true, then it implies that it's also true that if not Q, then not P. Okay? So a statement, the original statement here, and its contrapositive here are logically equivalent. So if one's true, the other one's true. All right? And the next thing we want to discuss is the chain rule of reasoning. This is kind of like the transitive property, but it's for logic. So if P implies Q and Q implies R, then P implies R. Okay, so if it's logically true that P implies Q and Q implies R, then P must imply R. Okay, again, that's like a transitive property. So to complete a chain of reasoning, you can rearrange the statements and use contrapositives as needed to match symbols. What the heck does that mean? Well, let me show you an example. And this is where we can use both theorem 3 and the chain rule of reasoning to complete a problem. I'm going to skip sample problem 1. You can look at that in the textbook if you'd like to. Sample problem 2, I think, is more fun and more interesting because it requires us to use contrapositives and chain rule of reasoning to make things work here. So let's take a look. So we're given this series of statements. Let's do what we're told here. We're supposed to draw a conclusion. So step 1 is we're going to read these confusing statements or strange statements. If gremlins grow grapes, then elves eat earthworms. If trolls don't tell tales, then wizards weave willows. If trolls tell tales, then elves don't eat earthworms. Okay, sounds like a tongue twister, but let's just try here. Step 1 says to rewrite the statements in symbolic form. And what I mean by that is I'm going to pick a letter for each phrase, each hypothesis and conclusion, and I'm going to write some logical symbolic statements. So for the first one, if gremlins grow grapes, that's a G, then elves eat earthworms. So I'm going to say G implies E. If trolls don't tell tales, so that's a not T, then wizards weave willows. So I'm going to call that W. And the last one, if trolls tell tales, then elves don't eat earthworms. That implies not E. Okay? So we've rewritten the statements in symbolic form. And these were nicely written for us as conditional statements already. So that's kind of nice. So let's take a look at step 2. Rearrange the statements and use contrapositives as needed to match symbols. Now what we want to do is we want to figure out a way to use the chain rule of reasoning to work from one end to the other. Now my advice is to look for the 2 letters that only appear once because those are going to be on the ends of our statements. Okay? And if I look at this, I see that I have a G and a W. I have two E's and two T's, so they're probably going to be linking in the middle somewhere. So I want to connect the G with the W by going through E and T. So let's start with, I'm going to number these, statement 1, statement 2, and statement 3. Okay, I'm going to start with statement 1. G implies E. Okay? I don't have another statement that starts with E. However, I've noticed that if I take statement 3 and write the contrapositive, negate both of them, and change the order, I end up with a new statement that starts with E and ends with not T. Okay, remember, contrapositive means I'm negating both parts and changing the order. Okay, double negation goes back to the original statement. Okay, so not, let me write this over here. So not E is the same thing as E. Okay, double negative. And finally, we can refer to statement 2 from above, which said not T implies W. So this, we can use the chain rule to apply. So we can go from G to E, then E to not T, and then not T to W. So we'll end up going from G to W. All right? G to W. So I'm going to put in here all of these things. Therefore, and those 3 dots mean therefore. Okay? Therefore, G implies W. And what that would mean is if gremlins grow grapes, then wizards weave willows. Okay? All right. So that brings us to the end of this video. Please do feel free to watch this sample problem 2 again if you want to get through it one more time. But thank you for watching, and I'll see you in class.